Differential Calculus 2011, question 10b. A particle traveling in a straight line has deceleration minus a of v squared over 400 plus 16 ms to the minus 2, where v is its speed at any time t. If its initial speed is 40 meters per second, find the distance traveled when it comes to rest and the average speed of the particle during motion. Okay, so we're looking for distance. Let's just write out these equations. ut plus a half at squared. The s dt is equal to u plus at, which is my velocity. So my velocity is u plus at. So dv dt is equal to a. Now I have my accelerations. This is my dv dt. So can I set up an equation with dv dt that will allow me to sub in the a and get back to s. So we have the s dt, which is velocity, and I would have to multiply this by dv ds to get dv dt. So my acceleration dv dt is equal to ds dt by dv ds, which is my velocity, by dv ds. So bring that down then. We have v dv ds is equal to v squared over 400 plus 16 deceleration, so it's going to be minus. So we want the s on its own and we want dv on its own. Might make sense to put this into a single fraction. V squared over 400 plus 16 over 1 is going to be v squared plus 16 by 400, 6400 over 400. So I can bring that guy down then. I'll leave the minus on the right hand side and bring the ds over. So v dv is equal to minus ds on the right, and on the left I'm going to have to divide by a fraction, which will be the same as turning it upside down and multiplying. So I may as well do that in this step. So 400 over v squared plus 6400, and then I'm going to divide by 400 to get v over v squared plus 6400. dv is equal to minus ds over 400. And now I need to integrate these things, and the limits I'm integrating with are initial speed of 40 and it comes to rest. So an initial speed of 40 is down here and it comes to rest. And to get s, it's going to be between s and 0. So we integrate this on the right. Well, it's a little bit tricky. Let's substitute in, if we let u equal v squared plus 6400, du dv is equal to 2v. So we want v. So when we want u and du is equal to 2v dv. So v dv, which is what we need to integrate, is equal to du over 2, or a half du. So we're integrating a half du over u. So if I just come in here, if we integrate a half du, we're going to get a half. So this becomes a half. And then the bottom, if we integrate u on the bottom, we're going to get the natural log of u, which is the natural log of v squared plus 6400. And that's between 0 and 40. And that's going to be equal to minus s over 400 between s and 0. So if we sub 0 in, we're going to get a half by the natural log of 6400. So that's 0 going in here. And then minus a half by the natural log of 1600 plus 6400. That's going to be 8000. And that's going to be equal to minus s over 400. So if I multiply by 2, or multiply by 2 and change the signs around, so well I'll do it in 2 stages. I'll change the signs first, or just multiply by -1 first. Keep it simple. So a half by the natural log of 8,000. This is to give me a positive s on the right, minus a half by the natural log of 6,400 is equal to s over 400. So if I multiply everything by 2, I put a 2 on top here, I'm going to get s over 200. So I get the natural log of 8,000 over 6,400 is equal to s over 200. So if I get the natural log of 8,000 divided by 6,400 and multiply by 200, I'm going to get s is equal to 44.6287. So s is equal to 44.629 meters. Part 2, we're asked to find the average speed of the particle during motion. So we know that average speed, what's average speed equal to? dst, distance over time, is equal to speed. So we have the distance, so we need the time. V is equal to u plus at. We have the acceleration, so dv dt, we know, we've done this a lot, is equal to a. So dv dt is equal to my acceleration, which was minus, let's just double check what it was, all the way back up, v squared over 400, which we simplified into this guy here. So this is my acceleration, and it's a minus v squared plus 6,400 over 400. So we need to get t on its own. So again, we're dividing dv divided by this whole thing. We'll be multiplying it by the fraction turned upside down. That's going to be equal to minus dt. So I'm going to have dv over v squared plus 6,400 is equal to minus dt over 400. So we're going to integrate these, and it started at 40 and it's going to come to rest, and we're looking for time, so between time and 0. So we have actually got two squares on the bottom here, and this may be easier to integrate. So between 0 and 40 of 1 over v to be squared plus 80 to be squared is going to be one of my ratios in the table, so that I can simplify down into tan. Let's just double check that. So 1 over x squared plus x squared plus a squared goes to 1 over a by the inverse tan of x over a. So we can use this here, equals minus dt over 400 between t and 0. So if we apply this formula here to my integration, I'm going to get 1 over a, which is the 80 bit, so 1 over 80 by the inverse tan of v, which is my x, over 80. And that's all going to be between 0 and 4, and that's going to give me minus t over 400. So we don't need the t and the 0 here. So if I multiply the whole thing by 400, I'm going to get over here, I'm going to get 400 over 80, which is 5. So I'm going to get 5 by the inverse tan. Well, maybe I should put my, well, I can do this in one step. I can't do this in one step. So I'm going to have 4 by the inverse tan of, this is the inverse, the tan of 0, 0, so I don't need the 0 part. So it's going to be 5 by the inverse tan of 40 over 80, which is 1 over 2, will be equal to my t. Or maybe skipping a bit, if I did put the 0 in, it'd be the tan. I might as well do this, the tan of 0 minus this, and that's where my minus will be able to disappear from. So 5 by the inverse tan of a half is equal to t, and if we type this into a calculator, This would need to be in radians, so we're going to have 5, but the inverse tan of 1 over 2 in radians is going to give me 2.3182 is equal to t. So my average speed is equal to, what do we get for distance? 44.629. 44.629 divided by 2.3182 will be 19.25. 19.25. We're talking about speed, so meters per second. And that's that question done.